Topic 1.2, problem number 5. We want to simplify these two problems. So, first let's take 16 and factor that. Let's try 8 times 2, and this factors into 2 times 4, and that factors into 2 times 2. Since it's a cube root, we want to find 3 of a kind. So all of that will be in 1. So everything in blue is 8. Outside of the blue is 2. Now we want this exponent to be in the 3 time tables to match with the index here. So we'll break this into this 5 into x to the 3rd power and x squared. We want this to be in the 3 time table, so we want this to be a 9. So we'll break this into y to the 9th times 9. The next part here, the 2 does not factor any further. The x squared does not factor any further. But the y to the 7th power, we're going to get that into 3 time tables by expanding that into y to the 6th times y. Again, we want the highest power in the 3 time tables here. Okay, so the 8 will simplify to the x cubed, the y to the 9th, and the y to the 6th. This simplifies to a single 2, this to x, and this to y to the 3rd. All this will go ahead here. This simplifies, when you divide this by 3, to y to the 2nd. And we'll transfer that to up front. So what we end up with is 2xy cubed outside, and what remains is a 2x squared y. Then here, the y squared goes to 5, so we get 5y squared. And what remains is a 2x squared and y. Okay. And since the indexes match and what's under the radicals, which we call a radicand, matches, these two can be added by putting these terms right here in one parenthesis. So 2xy cubed plus 5y squared. That process right here, putting them in parentheses, adds them. And then we put the root outside. Okay, now we're going to multiply using the FOIL because we have 2 binomials. So we'll multiply the first, the outside, the insides, and the last. So 2 square root of 5 times 3 square root of 5. The 2 times 3 gives us 6. And the square root of 5 times the square root of 5 gives us the square root of 25. On the outside, we have a 2 square root of 5 times a negative square root of 3. That gives us a negative 2. And the square root of 5 times square root of 3 is square root of 15. Inside, we have the square root of 3 times 3 and the square root of 5. That gives us positive 3 and the square root of 15. And the square root of 3 times negative square root of 3 will be negative square root of 9. Okay, now start simplifying. This will end up being 6 times, this simplifies to a 5. So 6 times the 5 will give us 30. These two can be added. We'll get a positive 1 square root of 15. And this simplifies to a negative 3. Now we can simplify the 30 and the 3 and get 27 plus the square root of 15. Next, again, we have 2 binomials. We want to FOIL these. That'll be the first, the outside, the inside, and the last. Multiplying the 2 and the 3, we get a 6. Multiplying the 3 and the I, we get a 3i. Multiplying the I and the 2, we get a 2i. And multiplying the I and the I, we get a plus I squared. The 6 does not simplify, but the 3i and the 2i add together and gives us 5i. I squared can be simplified to a negative 1. So now we have a 6 and a negative 1. Those two can be simplified to a 5 plus 5i. And lastly, we want to FOIL this as well, 2 binomials. first, then multiply the outsides, multiply the insides, and then multiply the last. Multiplying the 5 and 5 gives me 25. Multiplying the 5 times the negative 2i gives me negative 10i. Multiplying the 2i by 5 gives me positive 10i. And multiplying the 2i by the negative 2i gives me negative 4i squared. Then I'm going to go back and simplify this, simplifying terms. The 25 will not simplify. The negative 10i will combine with the positive 10i to cancel. And the I squared will become a negative 1, multiplying with the negative 4, making that a positive 4. The 25 and 4 together make 29. Okay. Here, we want to simplify or rationalize the denominator. So I'm going to multiply by the conjugate of the denominator, which is square root of 10 plus square root of 6. And then I'll put this also in the numerator to make it equivalent to the number 1. That means we're not changing this because this is equivalent to 1. Now we'll begin the process of foiling. First, outside, inside, and last. Square root of 10 times square root of 10 is the square root of 100. Square root of 10 times 6 is the square root of 60. Square root of 6 times square root of 10 is the square root of 60. And the square root of 6 times the square root of 6 is the square root of 36. Same thing with the denominator. We're going to FOIL this since these are two binomials. First, outside, inside, and last. Square root of 10 times square root of 10 is square root of 100. Square root of 10 times square root of 6 is the square root of 60. Negative square root of 6 times positive square root of 10 is negative square root of 60. And negative square root of 6 times positive square root of 6 is negative square root of 36. Alright, now we'll start simplifying these. The 60s, these 60s have a perfect root inside them. 4 times 15. And where I got 4 times 15 from was, if you break down 60, let's say 30 times 2, and then 30 into 2 times 15, and 15 into 5 times 3, you can see your pair here in the blue is 4, and on the outside is 15. So let's begin the process. Okay, this simplifies to 10. This simplifies to 2 and the square root of 15. This simplifies to 2 and the square root of 15. And this simplifies to a 6. This simplifies to 10. These two cancel each other out. And this simplifies to a negative 6. Okay. So the 10 and the 6 can combine to become a 16. These two can combine to become a 4 square root of 15. And the 10 and the 6 combine to become a 4. Now, since the 4 can simplify with both of these, I'm going to break the 4 into this fraction into two parts. 4 underneath the 16 and 4 underneath the 4 square root of 15. The reason why I'm splitting this up is because we can get more simplification. 16 over 4 simplifies down to 4. As 4 square root of 15 over 4 simplifies to the square root of 15. Okay. Once again, we want to rationalize the denominator. The I really is the square root of negative 1. So, since it's a root, it needs to be rationalized. So the conjugate will be 4 minus I, and then we'll write 4 minus I in the numerator, making this equivalent to 1. Multiplying this by 1 means that we're not changing the original problem. Okay, let's begin the process of FOILing. First, outside, inside, last. First, we have 4 times 4 is 16. Outside, we have negative 4i. Inside, negative I times 4 is negative 4i. And outside, we have negative I times negative I, which is positive I squared. Okay, now we're going to FOIL the denominator. And we have 4 times 4, and then 4 times negative I times 4, and I times negative I. The 4 times 4 gives us 16. The 4 times negative I gives us negative 4I. The I times 4 gives us our positive 4I. And the positive I times negative I gives us negative I squared. Now we'll begin to simplify this. The 16 does not simplify, but the negative 4I and the negative 4I combine to become negative 8I. The I squared here becomes a negative 1. 16 does not simplify. The negative 4I and the positive 4I, they cancel, combine and cancel. The I squared becomes a negative 1 with the negative, which becomes positive 1. Now we'll combine the 16 and the negative 1, and we'll get 17. We'll combine, the negative 1 and the 16 become 15. Sorry about that. And the 16 and the 1, they become 17. And so we have 15 minus 8I all over 17.